Hi, my name is Bill Hitchcock, and it is Friday, March 20th, 2020, when I'm recording this particular video clip. What I'm going to be showing you next is a series of three short clips. They all use financial functions, so this one is going to focus on the present value function. I've got a sheet set up, and up at the top I've just got in a little description about what and when we might be using the present value function. So present value analysis is often used to determine if you should take a lump sum or a series of payments, equal payments. So what I've got here is I want to do a quick analysis. What's going to be better off? Taking a lump sum of, and you type in the number. We could try like $1 million. Or if I was going to get a series of payments of $100,000 for 20 payments or 20 years, for example. And if you think about this, if I take my payments of $100,000 for 20 years, that's $2 million. Let's just multiply this out quick. 100,000 times 20. Gives me my $2 million. $2 million is certainly more than $1 million. But keep in mind, that's $1 million today. This one's paid out over a series of 20 years. So really what affects this is either an annual interest rate, in other words, what could you invest this $1 million at, and then find out what the total would be. Or another way of thinking of it is, think of this as like an inflation rate or something, a discount rate. I want to discount this and put everything in today's dollar terms. In other words, the present value terms. So as that interest rate goes up, or as that inflation rate goes up, the present value is actually going to decrease. So a couple things we can do. I'm going to type in my spreadsheet, I've got my payments, and I just typed in how many payments we've got, 20 payments here, and then I want to get the total of it. So let's put in my series of payments, so I'll say it equals this payment amount, and then I'm going to hit function F4 a couple of times, so I always reference cell B7. Hit enter, there's my $100,000. Now if I copy this down a couple cells, notice that it always references cell B7. Cell B7. It's always referencing $100,000. So let's copy that all the way to the bottom by double-clicking on the fill handle. And I come down here to payment number 20. And now let's put in our sum formula and sum all this up. I'm just holding my shift key, going up to the word series. So I'm summing up C11 to C32. Hit enter. There's my $2 million. Alright, well next what I want to do is compute out the discount factor. Now the discount factor is equal to 1 divided by, and then we're going to put in a parenthesis, 1 divided by 1 plus my interest rate or inflation rate or discount rate. And again, we'll hit function F4 a couple of times. And then I need to raise that to my payment number power. So in other words, if I don't get $100,000 until the end of the year, really it's not worth $100,000 today. It's worth something less than that because I could have earned interest on it. Hit enter. And my discount factor turns out to be 0.95. So it's worth 95% of that. I'm going to format that. Let's use a comma format. Let's increase the decimal out a couple. And then I can copy this discount factor all the way down. And actually, you know what I'm going to do? I think I've got these cells all at font size 10. Let me check some of the rest of these. Yeah, I've got everything in font size 10. So just to be consistent, I'm going to format all these cells as font size 10 as well. Alright, got that. And let's copy our discount factor down a little bit and see what happens. And notice, for getting $100,000 2 years from now, it's worth only about 91%, 86%, 82%, and so on. And we copy this down. So finally, to find out how much all this money is worth, my discount factor is, or my discounted cash flow, DCF, discounted cash flow, is equal to the $100,000 times my discount factor, and let's format that with a dollar sign. Probably don't really need the cents, so I'm just going to decrease that. It kind of displays it rounded off. Let's copy that down. And as you see, as we go out in the years, once I'm out to year 20, $100,000 20 years from now is actually worth only $37,689 if we had a 5% inflation rate. So let's take our sum, copy that over here, and we find out that the net present value, or the present value of all of these, that whole stream of numbers, is $1,246,221. So there's a shortcut way of doing all that instead of setting up this table, and we can do the present value. So I'll type in equals PV is my function. The rate is this discount rate or annual rate. The number of periods is the 20 periods. The payment is my equal payment, the $100,000. Type in a parenthesis, hit enter, and notice this number appears as a negative number because it interprets it as though it's a negative cash flow. So all I have to do to fix that is, for my payment, I can either put in a minus in front of the PV formula, and it multiplies this by -1, or I could have done it right in front of the B7 and put a minus sign in there, hit enter, and there it shows us the positive value of $1.2 million. That matched up with what we computed here. So, which one's better? Well, in this case, it's the stream of $100,000. My present value is greater than what the lump sum was. So I'm going to type in a nested formula here that says equals if, parenthesis, if the lump sum is greater than the present value, then what I want to say is the lump sum is better. But if it's not, what I want to do is I want to check and find out if these are equal to each other. So I'll say equals if, or just if the lump sum, in this case we'll just say, how about if we say if it's less than? If it's less than the present value, then we know that the stream of payments is better. But if it's not greater than, it's not less than, it must be equal to. So we'll just say it doesn't matter, they are equal. Put in a parenthesis to end this if statement, another one to end the first one, and we've got the stream of payments is better because the present value is higher. So let's try changing things around a little bit. What happens if our annual interest rate is 0%? There's no discount factor. And my present value is equal to just $100,000 by 20 payments. It's $2 million. Obviously, the stream of payments would be better. But if our inflation rate zooms up to, say, 10%, in that case, the present value is less than the lump sum. So my lump sum would be better. And then finally, to test out our equal, what we can try doing is, let's save this, and let's go to data, what if analysis, and I'll try a goal seek, and I want to set the present value to $1 million, 1, 2, 3, 4, 5, 6, and I want to change the annual interest rate. And it churns through, and it still says that the lump sum is better, probably because this actually doesn't take it exactly to $1 million. And I suppose what I could maybe do with this is use a rounding function to test that out. But chances are we're not going to get anything where the two end up to be perfect. And now this 7.75%, this is something that later we'll see is an item that's called our internal rate of return. So try it out. Try a few different formulas in here. Try your 4%. You can find out which tends to be better. Try 8%. We can find out the lump sum is better. And you can experiment with your present value.